Hello everyone. Today we're going to take a look at implicit differentiation. Now implicit differentiation comes from the fact that you can write any function basically in two different forms. You can write it explicitly, in which the dependent variable is explicitly written in terms of the independent variable, or you can write them implicitly, in which the dependent variable may be a little bit harder to define purely just in terms of the independent variable. So I have the chain rule written here as a reference point because implicit differentiation does rely heavily on the chain rule, because we're taking the derivative with respect to a variable that's not explicitly written in the function that we're trying to take the derivative of, but we know that that function depends on the variable that we want to take the derivative of with respect to. So, for our first example, we're just taking the derivative of y, and we have up here, let y be a function of x. So we're taking the derivative with respect to x of y, which is a function of x. So what we do here is we just treat y like we would any other variable that we're taking the derivative with respect to. And so if this was an x and we're taking the derivative with respect to x, this would just be 1. And that's correct, almost. But because y is a function of x and we're taking the derivative with respect to x, we have to multiply by the implicit derivative dy dx. So the derivative with respect to x of y is dy dx. Now our second example is a little bit more complicated, but it's a great example of why we need implicit differentiation. Because we have here an equation with two y terms that it would be pretty hard to simplify into just terms of y on one side and then x on the other side written explicitly. So we need to implicitly differentiate this to find the derivative of our function, which is y. So treating y like we would a normal variable, we get the same answer as we did up here. Move this over here. So that's just dy dx. And then the derivative of, with respect to x, of x cubed, this is in terms of x, so we differentiate it immediately with respect to x, or respectively. So it's like we would any other derivative, it's 3x squared, because we're differentiating with respect to the variable that it is expressed in. Okay, so now we have plus y squared. Treating y as a variable, our outside function is y squared. So the derivative of that is just going to be 2y. Now, for the chain rule part, we just multiply this again by dy dx. And now if we want to solve for the derivative of this, we subtract this over here, factor out a dy dx, so dy dx, and then divide 1 minus 2y, so we have 3x squared over 1 minus 2y. And that is the derivative of the function described by this equation here. Even though it has a y in it, this is a valid argument. This is the derivative because we differentiated every single term and accounted for every single variable that everything is dependent on or not dependent on, and we have our final result, which is dy dx is equal to this expression.